8.7, modeling with exponential and power functions. We're going to stick to the given 2 points, create a model. First of all, we are going to try an alternate path here, so disregard the directions for the working on this here. All right, we're going to go by these red steps here. We're going to create a system of 2 equations. Then we're going to divide. Instead of adding system equations together, we're going to do a divide step. And then we're going to go through the typical solve and substitute part here. So let me scroll this up here. So here we go. First of all, the exponential function is of the form y equals a times b to the x. Now, ordered pairs give us an x and y and an x and y. So we are going to create our system. So first of all, I'm going to choose the one with the bigger x value. So that's going to be this one right here. So I'm going to take that ordered pair and use this model. And now I'm going to say that 32 equals a times b to the second power. The second point, I'm going to set up in red here, and I'm going to say 0.0625 equals a, b to the negative 1. Now from here, we're going to go ahead and here's my system right here. So I'm going to take the top equation and divide it by the bottom equation. So I'm going to go ahead and put a divide bar here and a divide bar here. And when I divide 32 by 0.0625, I get 512. When I divide on the right side, the a is reduced to 1. And when I do this divide, I end up bringing that power up. So I'm going to end up getting rid of this, adding 1 here. The a is reduced to 1, and I get b to the third. Now on your power card, you should have 512 as a integer cubed, and it in fact comes out that b equals 8. So we got a pretty nice number here. Sometimes this can be an integer, sometimes it can be a fraction, sometimes it's a decimal. So in this case, we had a pretty good situation. Now, I'm going to go ahead and substitute this b value into one of my 2 original system equations. Well, I like the blue equation better. It doesn't have that decimal. So I'm going to go ahead and take this equation here with this value here, and I'm going to say that 32 equals a times 8 to the second power. Okay. So when I go ahead and solve this, I get 32 equals a times 64, and I get a equals 1/2. So I end up with my A piece and my B piece, so now I'm ready to write the exponential function for this modeling situation here. Final answer, y equals my A times my B to the x power. And we're done with that. So the system of equations method has its merits. So this is an exponential function. The key thing with an exponential function is that it has this form. Now when we go ahead and do a power function, we know exponents have powers, but they mean 2 different types of equations here. Again, we're going to disregard the 5 steps, and we're going to go again with the same set of steps here. They will look a little different, but in fact, we'll end up having a lot of similar type steps. Now, first of all, the power function is y equals a times x to the b. So that is the generic form. And again, we want to solve our system to find a and b, and then go ahead and I'll do some substitution here. Again, I want to take the bigger x ordered pair, and again I'm going to circle that in blue, and so I'm going to go ahead here and say my y, which is 12, equals a, my x is 9, and b is b. Similarly, I'm going to go ahead and take the other point and write it in red here. So I'm going to get 8 equals a times 3 to the b. So here's my system of equations here. And so I created my system. Now I'm going to divide equation 1 by equation 2. So again, I'm going to take this, divide it by this, and on this side I get 1.5. On this side, again, the a's cancel. And what happens here is that now I have 9 over 3, both raised to the b power. So let's rewrite it as a fraction raised to the entirely to the b power. Now from here, we're going to do some simplifying here. So I'm just going to bring this up here. And so that's really 1.5, 3 to the b. And again, that 3 could have been a fraction or decimal, but this is simplified nicely. And now to our normal way of getting at this, to get b by itself, is to rewrite this as a log statement, or log equation. So log base 3 of 1.5 is my b value. Now yes, we could get a decimal for this, but this is a pretty nice looking, somewhat complex, but nice looking expression for b. Now like we did before, we're going to take my value for b and use one of my 2 equations here. Now this time it looks like my red equation is going to be a good fit here. So I'm going to take my red equation and substitute b in for that. So I'm going to go ahead and I'll still have 8 equals a times 3. And now my power is this log base 3 of 1.5. Now looking at this, we say, holy cow, there's a lot of stuff going on here on the back end of this. But recall that when I have the 3 to the log base 3 of 1.5 power, these are kind of inverses of one another. So this will leave us with 3 with just times 1.5. So the base of the power and the base of the log are the same, so they kind of wipe each other out. They're inverses, leaving 1.5. So now we divide both sides by 1.5. And you could get the decimal of 5.333. I'm going to go ahead and I'm going to write this as a fraction of 16 thirds equals a, a. And what I did was multiply this by 2 and multiply this by 2. With 2. So let me just kind of multiply by 2, multiply by 2. So now I have my a, I have my b, and together I can write my power function I'm going to say I've got 16 thirds times x to the log base 3 of 1.5. Not the nicest looking thing, but it's pretty clean here. Pretty clean, so that is how we are going to go ahead and create exponential and power models.